Today we are going to learn how to solve one-step inequalities. The first two operations we are going to learn about are solving these inequalities with multiplication and division properties. We have a couple of important things to know though. When we multiply or divide each side of an inequality with the same positive number, the inequality remains true. When you multiply or divide an inequality by the same negative number, the inequality symbol must be flipped or reversed for the inequality to remain true. So let's see exactly what that means. Here we have example number 1. Our example is that 5 is less than 10. So if I were to multiply each side of this inequality by the same positive number of positive 2, 5 times 2 is 10. And 10 times 2 is 20. 10 is less than 20. Yes, that is still a true statement because I multiplied by a positive number. My inequality remains true. Let's try it with a negative number now. I have 16 is greater than 12. That's a true statement. If I were to sit here and divide 16 by a negative 2, that gives me a negative 8. If I divide 12 by a negative 2, that gives me a negative 6. So if I have this, I have a negative 8 is greater than negative 6 because I originally started out with a greater than sign. Negative 8 in my final answer is not greater than negative 6. So this is where we say the inequality symbol must be reversed. So if you notice right here that I took my greater than symbol and I reversed it or flipped it to a less than symbol to make my statement true. So we don't keep our symbol the same when dividing or multiplying by a negative number. We have to flip it for the statement to remain true. Let's practice this. Number 1, we have a negative 5x is less than or equal to 45. So if I have a negative 5x is less than or equal to 45, my first step was to rewrite the inequality. My second step is to solve. My problem is multiplication. So remember, just like in equations, if it's multiplying, I do the opposite to solve because I want my variable by itself. So in multiplication and division, I've got to get the number that's attached to the variable to 1. So I divide to solve, and then a negative 5 divided by a negative 5 is 1. And a 45 divided by a negative 5 is 9. 1 times x is x. And then looky here, we started with a less than or equal to symbol, but because we divided by a negative 5, we have to flip it in our final answer. So now we should have a more than or equal symbol in our final answer. So x is greater than or equal to negative 9. Our solution is x is greater than or equal to a negative 9. So let's say a negative 9 is right here. Let's finish plotting. Remember, when we go to the right in the negatives, our numbers get smaller. So we have a negative 8, 7, 6, 5, and 4. Negative 10, 11, 12, and 13. Now, this is a greater than or equal to symbol. So remember yesterday we learned that if it's greater than or equal to, if it includes the negative 9, we have a closed circle, and then we're going to bold out the rest of the line to show that it goes past and all the way through the arrow. Let's practice again. Solve x divided by 8 is greater than 3, and then we'll represent it on a number line. So we're going to rewrite this. X divided by 8 is greater than 3. Our problem is divided by. So we need to get our variable by itself, so we're going to multiply. So let's rewrite this. X divided by 8 is greater than 3. As soon as I decide that it is multiplying, I'm going to write these dots on each side of my inequality to show that I'm going to multiply. Then I pick the number that's on the same side as the variable, which is a positive 8, and I'm going to write it on the other side of the dots. So we have already learned that if I am having an 8 in my numerator and an 8 in my denominator, that will cancel out to be a 1 because x will leave by itself. So then I have a 3 times 8. A 3 times 8 is 24. So did you notice that we kept our inequality symbol the same? We started with the greater than symbol, and we ended with the greater than symbol. That's because our problem did not call for us to divide or multiply by a negative number. We did by a positive number. So we only flip the sign when multiplying or dividing by a negative number. So we will stay with greater than, and our solution is 24. So let's say 24 is right here on the third line. I would like you to fill this out on your own because you learned how to do it yesterday, and then we will check your circle and the rest of the number line tomorrow to make sure you did it correctly. Let's move on. Number 3 says a negative 10x is less than or equal to 80, and then we'll represent it on a number line. Negative 10x is less than or equal to 80. It's multiplying, so we're going to solve by dividing. So let's draw our lines, fractions as division. We divide by the number that's on the same side as our variable, so that number would be a negative 10. Now we are dividing by a negative 10, so we will need to flip. I would like you to try to finish this problem on your own, and whenever you feel confident, you may press play to check your answer. Okay, so because we were dividing by a negative number, we had to, in the end, flip our inequality symbol. So we went from less than to equal to greater than or equal. So again, because we learned this yesterday, I would like you to practice your number lines with inequalities, and we will check that tomorrow. Once you finish your number line, we have one more problem that we are solving, and we are going to be practicing this x divided by a negative 6 is greater than negative 7. So I would like you to try this one on your own, and then we will check your answer tomorrow.